Welcome back, it's me, Mr. Truin, and today we are going over a new lesson in geometry. We're going to be looking at two different terms, one called a circumcenter and the other called an incenter. And we're going to show how each of these terms relates to a point of concurrency of a triangle. So our first one is called a circumcenter. And by the way, I didn't say it, so maybe I should back up and say what it is. A point of concurrency is where two or more segments or lines come together at a common point. So in this case, a point of concurrency that we're going to be looking for is three perpendicular bisectors of a triangle. So I'm going to take and find the perpendicular bisector of three sides of this triangle, figure out where they come together, and that's called the point of concurrency. And it's going to be something called a circumcenter. And I'll explain that later. So, first one I'm going to go over, I'm going to look at segment BC. So on segment BC, if I found the center or the midpoint of BC and I drew a perpendicular line, I'm going to do that line dotted, that would divide BC into two congruent segments. And then if I do that on AC, I think it's about right there. Again, I'm going to do my best. I need to put a letter there for each one of these. As I do each one of these, I am just going to be kind of eyeballing it. And then the third one, again 90 degrees. They all come together at this point. I'm going to call that point, let's call it W. W is the point of concurrency for the three perpendicular bisectors. Now, how is that relevant or useful in any way? Well, that's where I need to explain what this is accomplishing. When I draw these three, the point where they come together is what we call equidistant from each of the vertices of this triangle, meaning it is the same distance from W to B as it is from W to A, as it is from W to C. So I'm going to write that statement out real quick. WA is congruent to WB and WC. So we are equidistant from W to each of the three vertices. So a perpendicular bisectors, when we bring them all together, they make us equidistant from each of the three vertices. Now, we call it a circumcenter because this point is the center of a circle that goes around, like the circumference of a triangle. So we have circumference of a circle, which is the outside of a circle. Well, the circumcenter is going to be a circle that goes around this triangle. So I'm going to try to use my whiteboard marker here, or whiteboard compass, and see if I can draw a circle. And if we put that circle, center it at W, and we go from W to any of the 3 points. If we were to go around, already I'm failing at this. It's sliding all over the board. Oh, it's terrible. I'm going to scratch that and go with my old-fashioned way of doing it, which is I take a piece of wire or string. I'm going to put that at the center. I'm going to put my finger there, and I'm going to take the cord and go to that point. And it's not the best, but it'll do. But it is the center. W is the center of a circle that goes around the triangle in such a way that the distance from the center, W, to each of these points is the same. It is the same distance from the center for each of these. And that's called a circumcenter. So the next one we're going to look at is called an incenter. So when I do this one, I'm going to be looking for the point of concurrency for the three angle bisectors. So first thing I'm going to do is, again, I don't have anything to really measure this with to the best of my, so the best I'm going to do is eyeball it, but I want the angle bisector. So if you imagine this is angle A, and if I was to split this right down the middle, it looks like it would be somewhere like this. Again, I'm just going to do the best I can.
Teachers and staff, please pardon the interruption. We will have our fire alarm go off. There's no need for alarm. It's just a test of the fire alarm. Again, the fire alarm will sound.
It's going to be the best video ever. We're about to add a fire alarm to it on top of it being after school program. So anyways, before this goes off, here's what we have. I've drawn 3 angle bisectors, so each of these is congruent, creating congruent triangle or congruent angles in each of the 3 corners of the triangle, each of the 3 vertices. And when they come together, now I have what's called the incenter. And how that's relevant is this. The incenter is the same distance from the center of the circle to each edge. So if we say, for example, this point right here, and I call that point, say I call that W. And I call this one X. And I call this one Y. The distance from the center of the circle to the edge on all of these is going to be the same distance. Each of these, again, we measure distance 90 degrees, but each of these comes out to be the same value. So when I measure them out, if I put letters for each of those, maybe I call them Q, R, and S, what would I end up with? And I need a letter for the one in the middle. Let's call that one D. DQ is going to be congruent to DR, which is going to be congruent to DS. All of these 3 things are going to be the same distance from here to the edge, from here to the edge, and from here to the edge. So we call this the incenter. And the reason being is it's going to be the center of a circle that is inside the triangle. So if I'm going to try again with my old-fashioned way of doing this, I'm going to try to draw a circle that is inside the triangle, which is really difficult, but it ends up being so that the center, D to the edge, D to the edge, and D to the edge is always going to be the same. And so when we look at an incenter, and this is a really terribly drawn circle, but when we look at the incenter, it's a circle in the triangle, whereas circumcenter is a circle outside the triangle. This one, the same distance to the edges, whereas this one's the same distance to the vertices of the triangle. So I hope this helps. This is pretty much all I got, and I'm sure this fire alarm is about to go off and make this video weird. So anyways, thank you. Bye.